Okay, welcome to the electronics class for November the 9th. So I've looked over many of the homework assignments that you guys turned in. I didn't have time to look at all of them, but the ones that I did look at, they looked pretty good. Let's look at a few of them. All right, so you right now are looking at, I think Henry, is this one yours? Pretty
Yeah,
sure.
that
Okay.
one's mine.
All right. Okay, so let's zoom in a little bit so it's easier to see. And, okay. All right, so let's go ahead and start the simulation now. So Henry is claiming that this is an AND gate. Let's see if we believe that's true. So if it's an AND gate, then when I push one button, the output should not come on. Good. When I push the other one, the output should not come on. So the only way it would come on is if I push both of them at the same time, which you do by holding down the shift key. Hey, look at that. Okay, the AND gate works really well. Let's come over and look at this one. This one he's claiming is an OR gate. So the output should come on regardless of which one I choose. Yep, there's that one. Yep, there's that one. And if I turn on both of them, then yep, okay, very good. All right, so Henry definitely, he gets credit there. Okay, now here is another one. Looks pretty similar here. So let's skip over that one. Here's one. Now notice, let's see, I think this one is Luke's. Luke, do you claim this one?
Yeah, that's mine.
Okay, now notice that Luke decided that instead of using 4.5 volts, he wanted to use 9 volts. So that means he's going to have to use different values for his resistors, but hey, that's fine. I never put any limitations on what voltage to use. Okay, now Luke is the one that likes to use those weird switches. So Luke, let me just ask, in the future, please use the push button switches because they do have an advantage that we'll talk about later. But
right.
Hey, I never said you couldn't, so fine. Let's see if this works. So I don't know whether this is the AND or the OR. Let's find out. Okay, so when I turn on that switch, I don't get any output. So it must not be an OR. Let's try that one. Okay. All right, so, okay, yep, that one definitely must be the AND gate. Very good. And then let's come over here. Let's check this one. So this one then must be the OR gate. Let's see if it works. So if I turn this one on, yep. And then if I turn it off, then try this one. Yep, okay, so that's his OR gate. Okay, very good. And now let's see, what's this last one here? This one I think is Presley's. And he didn't label his, so let's see if we can figure out which one's which. So the one on the top here, if I click that one, okay, so nothing there. So this must be the AND gate. So let's try that together with that. And yep, okay, the one on top is definitely the AND gate. And so then this one must be the OR gate. So let's see if that's true. Yep, that works. Yep, that works. Okay, great. So that's his OR gate. Okay, so you guys, you did quite well there. At least those of you that I've looked at. Now, as of about 10 minutes ago, I noticed that there were still 5 of you who had not yet turned it in. So what I normally do is a finger wag in a case like this, but I'm starting to think that a finger wag isn't severe enough. I need to find something a little more motivational than that. Guys, you've got to turn in the work. And you've got to turn it in on time, because if you get behind, then you really have trouble. Because if you didn't do last night's homework, you're going to have a devil of a time doing tonight's homework. So it's really important that you do that. Okay. Are there any questions before I start talking about tonight's homework? Not hearing any, not seeing any. Okay. All right, let me go ahead and let's share my screen here. Let's go into the modules. All right, so last night you had to use transistors to build an AND gate and an OR gate. Tonight, I'm going to have you do something where you're going to have to do multiple AND and OR gates. Okay, So what you're going to have to do is you're going to have to combine a whole bunch of OR gates and also a whole bunch of AND gates. And it's going to be really, really difficult to do if you do it the same way that we did last time. So I'm going to allow you to use a new type of electronic component, one that we have not yet talked about. We're going to talk about something called an integrated circuit. So before you can understand what an integrated circuit is, you first need to understand what a discrete circuit is. And so the things that we've been working with up until now. So like we've been taking a transistor that's in one package and another transistor that's in a different package. So we say these are discrete components. And then we combine them together with resistors that come in different packages. So we got all these different components that are all separate, or at least when we, before we stick them into the breadboard, they're all separate devices. So we say that these are discrete components. So when we made our logic gates up until now, we made them out of discrete components. And so if we wanted to combine a whole bunch of AND gates and a whole bunch of OR gates and a whole bunch of NOT gates into some really complicated system, which by the way is what we're going to do next time we meet, okay, I'm going to teach you guys how to add 2 plus 2. So when you go home at the end of, not today, but next time on what's today? Today's Monday, right? Okay, so when we go home on Wednesday and your mom asks you, what did you do in school today? You can say, I learned how to add 2 plus 2 using electronics, okay? So, but in order to do that, we're gonna have to combine together a whole bunch of AND gates and OR gates and NOT gates. And so if we were to build this binary adding machine out of discrete components, oh boy, would that ever be a mess. That would be horrible. So what we're going to do instead of using discrete components is we're going to use what's called an integrated circuit. And so I'm sure you guys have seen these integrated circuits before. If you were to look on an Arduino, okay, so here's an Arduino, and you'll see that this thing right here that looks like a centipede, and it's got a whole bunch of legs on one side and a whole bunch of legs on the other side, and it's been soldered into this board. This is an integrated circuit. So it's got thousands and maybe even hundreds of thousands, and in some cases, maybe even millions or billions with a B of transistors and resistors, all shrunk down super, super, super small, and all combined inside the same package. And all of those elements have been integrated together. And so that's why we call them an integrated circuit. Okay, so what you're seeing right now on the screen is an integrated circuit that has 4 AND gates built into it. So you may remember, in fact, tell you what, let's go back up here. Okay, so an AND gate, when you guys made it from discrete components, it took you 2 transistors and 3 resistors to make an AND gate. So what you see here, actually, let's go back to here. This symbol that you're seeing right now, that is a generalized schematic that means AND gate. So it's got an input here, it's got an input here, and it's got an output there, right? So if the input is low and the other input is also low, then the output is going to be low. If one of the inputs is high, well, that doesn't do it, because as long as the other input is low, the output's still going to be low. Same with this one. Sorry, that's not going to cut it. The only way you can get a high output is if both of the inputs are high. Okay, so this symbol that you see right here, that is the schematic symbol for an AND gate. And so it uses 3 resistors and 2 transistors. Okay, so inside this integrated circuit that you're looking at right now, there are 4 AND gates built inside that thing. So that means that, so 4 times 2, so that means there's 8 transistors and 12 resistors all combined together inside this package here. Now, the way that an integrated circuit works is that first off, the thing needs to have power in order for it to even work at all. And so this pin right here, which is here, okay, this is called pin 14. So what they do is you look for this notch here. In black, doesn't show up very well. And you see that notch right there? That notch is the same as this notch right here. And so if you start at the notch, then this pin is 1, this is 2, 3, 4, 5, 6, 7. And then on the other side, it goes with 8, 9, 10, 11, 12. So when you get to this pin on the end here, okay, this is pin 14, and pin 14 is the one that we connect up to VCC. VCC stands for the voltage that we're using for the common cathode of our transistor. So basically, it's where we put in the plus voltage. So when you connect up your integrated circuits for tonight's homework, because that is what you're going to be doing tonight, make sure that pin 14 gets connected up to the plus side of the battery. Now, last night, when you guys were making your circuits, some of you used 3 AA batteries, which gave you 4.5 volts. Others of you used 9-volt batteries, which was perfectly fine, as long as the resistor was appropriately sized for 9 volts rather than 4.5 volts. Well, with an integrated circuit, okay, they are designed to have 5 volts on the VCC. They're designed to work with 5 volts. Now, there is some tolerance, as you can see right here. If you go as high as 6 volts, no harm done. If you go as low as 2 volts, it'll still work. But if you let the battery be anything less than 2 volts or anything more than 6 volts, then your circuit's either not going to work or you're going to blow out your IC. If you put more than 6 volts on there, you can destroy the IC. So in tonight's homework, when you guys use the integrated circuits, make sure that you keep the voltage somewhere between 4 and 6. So I would recommend that you use 3 AAA batteries so that your voltage is 4.5. That is clearly well within the range here. And so these circuits will work they'll work wonderfully with 4.5 volts. That's what I recommend that you use. Okay, now this pin right here, this is pin 7. So this pin needs to be connected up to ground. So the first thing you need to do when you plug the integrated circuit into your breadboard is connect up pin 14 to your positive voltage and connect pin 7 to the ground. Otherwise, nothing else is going to work. Okay, so now these 3 pins, let me clear this out. My drawing's getting kind of cluttered here. So these 3 pins that you see right here, they are these guys. So those together make up one AND gate. And so you don't need to worry about the transistors and the resistors. They're already built in for you. They're hidden inside. So this is your input number 1, which we call A. This is your input number 2, which we call B. And this is your output, which we call Y. So if A is 0, B is 0, Y will be 0. But if A is 1 and B is 1, then Y will be 1. Okay, so that's how it works. And then same thing, these guys right here, actually, let me do that in a different color. Okay. So these guys right here, they are them. And then these guys right here, they're the ones on that side. And then these, oops, actually, no, I'm sorry. did that wrong. They're closer to pin 14. Let me fix that. These guys right here, they are the 3 pins right here. And then these guys here, they're the pins that are on that side. So you see how we're able to get 4 AND gates all jammed inside of one little package. And they're all connected together in a way that we say that they're integrated. So we call this an integrated circuit, which is also abbreviated as IC. So that's what an integrated circuit is. Okay. So you're going to be working with these tonight. So here you can see inside the circuit, those are all the resistors and the transistors. They're actually inside the circuit. Okay, so now Tinkercad has integrated circuits in it. Now the thing is that if you want to use the integrated circuits, you have to switch the components to all. If you've got it set for basic, you won't find them. But if you switch it to all, they're there. Okay. And so the AND gate is this one. And you'll notice they have numbers on them. These are the same numbers that you'll find on a real integrated circuit. And so the AND gate is, the code number for that is 74HC08. The OR gate is this guy right here, 74HC32. And then the NOT gate is also called the hex inverter. So if you look in Tinkercad, if you look for a NOT gate, you won't find it. But it's called an inverter. Now, the reason it's called a hex inverter is because there are 6 of them. Because with an inverter, you don't have 2 inputs, you only have 1 input. So with our 14-pin package on our IC, we can fit 6 inverters in there rather than just 4. So that's why I call it a hex inverter. And these other ones, they're called quad NAND gates or quad OR gates or quad whatevers. Okay. All right. So what you're going to be doing tonight is you're going to be building circuits where you combine a bunch of different AND and OR and NOT gates to give a specific output. All right. So this is what I'm going to have you guys build as your homework for tonight. So you can see we've got 2 AND gates, 2 OR gates, and 1 NOT gate. Now, before we actually build the circuit, let's just go through and let's predict what the input and output should be, let me rephrase that, what the output should be for various inputs, okay? And I want every one of you guys to do this yourself. Well, actually, tell you what, let's do one together, and then I'll have you guys do the rest of them. Okay, so let's do this very first case here. Let's assume that we have this as our input. Okay, so A input is going to be 0, B is 0, C is 0, D is 0. Okay, so that means we have no voltage on any of our input pins. So if we look at the AND gate, let's see what happens. So we've got a 0 there and a 0 there. So the output of the AND gate is going to be a 0 because it would only be high if both of its inputs were 1s. Right now, how about the NOT gate? The NOT gate, the input is 0. So the output is going to be 1 because that's what NOT gates do. They make the output be whatever the input is not. Okay. And now watch this. So this signal, now it has voltage. So that's going to get transferred onto here. So the 1 from our NOT output becomes the input for the OR gate. And it also becomes the input for our AND gate. Okay. All right. Now our D input is 0. So that means that our input to this AND gate down here is 0. So this AND gate has an input where one is high, one is low. So that means the output from the AND gate is going to be a 0. And that 0 gets fed in down here to the OR gate down here, so it's a 0 there. Now let's track our way through here. So let's look at this, the output from our very first AND gate in the upper left here, that was a 0. So that 0 gets transferred in here, that becomes a 0. So now if we look at this OR gate, it has a 0 and it has a 1. So the OR gate, it will give us a high output as long as any of the inputs are 1s. So the output for this OR gate is going to be a 1, and that 1 gets transferred over to here, so it becomes there. All right. So the very final gate in our chain here is an OR gate, and one of its inputs is high. That means the output is going to be high. So that means Y is going to be a 1. So we can go ahead and we can fill in that the output for that first row is going to be a 1. All right. So does that make sense to everybody? So give me a yes or no. Okay. Yes means that this makes sense and you got it. No means you'd like to go over another example. Okay, I'm seeing a lot of yeses. Okay, so here's what I want you guys to do. So let's say this is row 1, 2, 3, 4, 5. Let's have you guys do so we've already done 1 together. So I want you guys to go through and figure out what is the output going to be for rows 2, 3, 4, and 5. And then I want you to type into the chat box in a private message, not a public message. I want you to tell me what is the output for each of those 4 rows. You can stop when you get to row 5. I think by the time you get to row 5, you'll have it down. You don't need to do more than that. Okay, so you guys go ahead and get working on that. I'm going to pause the recording because I anticipate it's going to take you several minutes to do this. So let me pause the recording temporarily, but not everybody. Okay, so I just turned the recording back on again, by the way. Okay, so Lily, would you be willing to do this last row for us? Will you tell me what to do and I'll do it. But what we want to do is we want to do the very last row. Okay, so Lily, tell me what to do.
I'm not very good at explaining things.
Okay, what is A?
0.
Okay, so then what I think I need to do then is I need to put a 0 in there. And so that means I'm going to have a 0 right there. Okay, now what about B?
0.
That's a 0 also. So it goes right there. That may look like a 6, but it's a 0. Okay, C, what is C?
1.
It's a 1. And what is D?
0.
Okay, so that 0 there gets transferred down here. Okay, so that's a 0. Okay, so now Lily, I want you to look at that first AND gate. So given that the inputs are both zeros, what is the output of that AND gate going to be?
0.
Very good. Okay, now I want you to look at the NOT gate. Given that the input to that NOT gate is a 1, what is the output going to be?
1.
If the input is a 1?
Oh, 0.
Yeah, because the way NOT gates work is they make it so the output is whatever the input is not. So if the input is high, the output is going to be low. Okay, and so by the way, that 0 is going to get transferred to here. And that 0 is also going to get transferred over to here. And the 0 up here gets transferred down to here. Okay, so now look at the OR gate. Both of the inputs to that OR gate are 0. So what's the output going to be?
0.
0. And that 0 is going to get transferred down to here. Okay, now look at the second AND gate. Both of its inputs are 0. So what's its output going to be?
0.
0. And that 0 gets transferred into here. All right, so the very last one, we've got an OR gate. Both of its inputs are 0. What's its output going to be?
0.
Okay, so the final output then for the entire circuit then is 0. Okay, so your homework assignment for tonight is to build this. And just so that you can see that it really can be done, let me go into Tinkercad here. And let me just go and show you what I did. And let's talk about how I did it. Now, I realize that some of you, you're probably already you've probably already opened up Tinkercad and you're probably already busy. So if you don't think you need to watch what I'm about to do, then hey, that's fine with me. But don't log off from Canva, or don't log off from Zoom yet, please. Stay on Zoom for just a little bit longer. All right, so this is the homework assignment for tonight. And so let me tinker this. Sometimes Tinkercad is really slow at opening up. Come on. Do, 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 do. Do, 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 do. Boy, it's never taken this long before. This is terrible. What is going on here? I'm starting to think that something locked up. So, you know what I'm going to do? I'm going to cancel this. I'm going to try it again. Okay, so Tinkercad is still alive. That's good. Let me go into circuits. And okay, so let's try to tinker this. Okay, hopefully it won't take so long this time. Wow, maybe there's a lot of people all using Tinkercad at the same time. This is not good. Well, I think I have a copy of the picture here somewhere. Let me. Okay, I do actually have a copy of the picture here in the PowerPoint. So let's see. Oh, you know, I'm beginning to wonder if it's my computer that's goofed up. Okay, hang on a second.
Love technology.
Yeah. My mouse all of a sudden isn't working, so I'm beginning to think that the problem is my computer. Okay. Did Tinkercad ever come alive? No, still not dead. Okay, so tell you what, let's, instead of doing Tinkercad, let's go into, I have a picture of what I did here. Okay, so this is the thing that I created using Tinkercad. No, not that one, this one. Okay. So one thing that is not shown is the voltage source. I zoomed in on that because I didn't, I didn't want everything to be so small that you couldn't see it. So over on the left side here, I have 3 AA batteries. So it's 4.5 volts. And you can see I've got the red line coming into this row right here. Actually, let me make that be red. Nice thing about this. Okay, so this row right here, and notice I used 2 breadboards here, and I have a jumper wire here connecting the 2 of them. So anything that gets plugged into this row up here is going to see 4.5 volts. And then my black wire is connected into the top row. So anything that gets plugged into this row here, and again, I've got a jumper there to carry it over to here. Okay, that's going to be ground. All right, so the first thing I want you to notice here is when I plugged in the integrated circuits, I plugged it in so that pin 14 is connected to the plus volts. So you guys need to do the same thing. your integrated circuits won't work if you don't give them power. Right? So the pin 14, which is the one in the upper left-hand corner, that needs to be connected to your voltage. And remember, if you connect it up to 9 volts, you're going to destroy your IC. The most they can handle is 6 volts. Okay, and then also don't forget that pin 7, that's the pin that has to be connected to ground. Now my ground is way up here, but the pin 7 is on the bottom part. So you'll see what I've done here. I've taken a jumper wire that goes all the way down to here so that I have 2 grounds now. So I have a ground up here on the top, which it turns out I'm not using right now. Well, actually, I'm not using for my integrated circuits, but I do use it over here. What I've got is the ground lead from my LED goes through a resistor to that. So you can see I am in fact using the ground up there. I didn't really need to connect it over to here, but I did it just because I like to be complete. Okay, so my 3 integrated circuits, this guy is grounded, this guy is grounded, this guy is grounded. So if I don't give it power and if I don't give it a ground, then they're not going to work. So make sure that the first thing you do when you bring in the ICs is give them power and give them ground. Okay, next, you'll see that my input buttons are basically the same input buttons that we've been using up until now. And here, Luke, this is where it's really important to use push buttons. It's going to make life a whole lot easier if you use push buttons here. Okay, so you can see that this light is on, so that means that this button has been pushed, and I was holding down the shift key when I did it. And this light is on, so that means that this button has been pushed, and again, I was holding down the shift key when I did it, right? But this light is not lit, so that means that the input here is a 0, the input here is a 1, the input here is a 0, and the input here is a 1. So if you look on my truth table up here, you'll see that 0, 1, 0, 1. Yep. Okay. And now you can see that the output, this light right here, this is my output, and it is lit. So that means that my output is a 1. Right? Now, what I'm about to tell you guys is really important. You see the way that I've done my wire management down here. I didn't need to do it this way. You know, what I could have done was I could have run a wire from here over to, here, and from here over to here and here. And then, I could, and boy, but, it would have gotten to be so messy because there's so many wires. It would have been impossible to figure out what wire is connected to what. So it's really important that when you're doing wires, do them the way that I have done. Okay, so have the wire come out, follow along here and go in. Okay, so I can see that my A input goes directly into this gate, and this is an 08, so that means this is an AND. This guy here is a 3-2, that means he's an OR. This guy here is an 04, that means he's a NOT. Okay, and so I've got my A hooked up to one of my inputs from my AND. See how that works? And so if we go back and we compare that, so you see here, you can see that the A input goes into an AND gate. And
You're muted.
You're muted, sir.
how long have I been muted?
Just like 10 seconds.
5 seconds.
Oh, okay. All right. Okay. Yeah, when I switched there, sorry, I muted. Okay, so what you can see here is I've got my A input goes to an AND gate, and my B input also goes to an AND gate, right? So if we go back and we look here, you can see that that is in fact exactly what happens. Okay, my A input goes from here into there, and so that is one of the inputs of the AND gate. And my B input goes in, okay, and it goes into the very same AND gate. Right? So does this make sense, guys? So, and now Tristan is saying, does the D input even matter? Okay, very good, Tristan. I'm really glad that you noticed that. Yes, you are correct. In this particular instance, the D input doesn't really matter. It's the C input that controls it all. So very good. Okay, so let me just go really quickly to, oh, okay, hey, Tinkercad finally came alive. Okay, good, good, good. Am I sharing Tinkercad with you guys now? Can you see my Tinkercad screen? Okay, good. All right. Okay, so let's see if it works, guys. Let's start up the simulation. Let's see if it works. So there's the simulation. Okay, so right now, all of my inputs are zeros, and you can see my output is a 1. So what if I turn on one of them? You see the output stays high. What if I turn this one on? Oh, hey, the output went low. Okay, so right now my input is 0, 0, 1, 0, and you can see my output is low. Okay, so how can I make that output go low? Okay, it looks like if I just go with one light on at a time, okay, the only way to make that output go low is if I turn on input C. Okay, the rest of them, that output is going to stay high no matter what. Okay, but if I turn on combinations, what if I turn on A and also B at the same time? Oh, okay, that didn't do it. The output stayed high. Okay, so you see how it works here? Boy, that output just wants to stay high no matter what. Okay, well, there it went. Now the output went low. Okay, so you can see this circuit that you have in front of you right now, that circuit is exactly the circuit that you guys need to build. So that is your homework assignment. So if you go into Canvas, you'll see 4-5 where it says multiple combinations of multiple logic gates. So if I click on that, and then I click on preview, so it looks like what you guys are going to see. Okay, so here is the logic diagram of what I want you guys to build. So I want you to build an actual circuit, and then I want you to tell me what is the output for these various inputs. And I want you to calculate the output 2 ways. One is I want you to follow through the logic tree here using a paper and pencil. And I want you to calculate what should the output be, just following through here using a paper and pencil. And then I want you, and then after you've built your Tinkercad creation, I want you to actually put this input into your creation and see if the output is what you predicted. So what I've done here is I've given you several different input values. So I want you to calculate the output both ways, both using paper and pencil and using your circuit. And then the very last one, the one that's worth 5 points here, is I want you to send me a link to your circuit so that I can verify that you actually have built the circuit the correct way. And as usual, remember, don't just send me the URL up at the top of the page. That won't work. You've got to click share, and you've got to click invite people. Otherwise, I won't be able to open it up. Okay, well, that's your homework. If you have no questions, you can type bye into the chat box and you can log out. If you do have questions, go ahead and ask your questions now. And if you want, I'll turn off the recording so that your question won't get recorded. That way you won't be embarrassed.